Hello and welcome to another edition of IESA Chat Show. The first three editions were speaking on global trends, and we came down to India in the third chat show where we focused on EMS, with government bringing down the directive to have domesticate EMS in India. In this chat series, we talk about two other elements which constitutes BESS and who are a critical part of BESS. One, of course, is PCS. The second part is containers. Two of the facts where people are looking into, and all of a sudden, and not all of a sudden, but specifically over the last few months, the importance of containers at least have increased multifolds. PCS always has been in demand. It is nothing new. It has been with wind, it has been with solar, it has been with now with batteries. So I have a great panel to moderate today. We have Abhishek Singh from Ogo Energy. We have Rudra Shriram from DCM Shriram. We have Ankush Raina from Jupiter Electric. We have Yogesh Bhardwaj from CHINT Green Energy. So welcome all of you. And we have Shreyas from CHINT also. So thank you for being on the panel today. And yes, so my first question, I would like to get to the introduction round a bit more creative than what we do. So a question along with your introduction. So Rudra, the question to you is, how do you see this industry today, and how would you like to see it by the end of the decade?
By the end of the decade, that's a tall ask. See, I see the industry in India, right? So we just talk about India because that's why we're all on the call over here. It is nascent. It is dynamic. It is ever changing, like any new industry would be there. Um, I think where I expect it to be in the next 10 years is definitely on top of the global standards, which is a really tall ask. When you talk about containerized BESS, I mean, and there's some people over here who are actually doing the real legwork apart from us on this. This is changing on a weekly basis. It's not even a, monthly or quarterly or, annual basis. In a year, we've seen 20-foot containers with a capacity of let's say 3 to 3.8 megawatt hour, going up to 5.5 already. So that's a huge jump. We're almost doubling capacity in the same space, and this is ever changing. I mean, we're working on projects that's already past that capacity. Obviously, ceteris paribus, there's a lot of let's say variables in that discussion. So I feel it's an extremely nascent industry. It's got the correct vibe, it's got the correct direction, it's getting some sort of governmental support. Everyone needs a lot more government support. That's always there in any new industry. In a decade from now, we must aim to be one of the market leaders. And I'm not going to, make this fancier and say we need to be the market leader, because we all know the limitations in that. But in terms of our young workforce, in terms of our engineering capabilities, we can definitely be in the top 5. And I think that's a fairly tall ask for even a decade of work in such an industry. Keeping in mind, you're tying in electronics with semiconductors, with mechanical engineering, with civil, with land, with real estate. It all comes together to give the complete solution.
Right. Thank you. Yogesh, the question to you is from, I pick up a leaf from what Rudra said, that it changes every week. And we have been hearing that, right? 2 months back, the norm was 314 milliamp cells. Today, we are talking of 528 with announcement making of 1175 milliamp cells. So has been the container, 5 megawatt hour, 6 megawatt hour, 9 megawatt hour. Okay, so this has been the announcement. How do you see yourself pertinent or making, how do you see your products are pertinent to these changes?
Yeah, thank you. Thank you. They and see, we have been in the industry for more than 20 years. CHINT has been manufacturing power electronics as well as some other storage product from long time, and especially in the utility scale as well as the C&I scale, we have been manufacturing the storage for more than 6 years now. And so what we have seen in the past that in a, you can say industry which has evolved from a 58 cell to 314, which is a mainstream cell at this point of time, is going towards 528 and 548. Until now, what is happening that till to 2024, let me say end of last year, until now, let me put it this way, that whatsoever are being you can say utility scale containers which are in operation, you can say majority of them are built on 314 Ah of the cell. But what we have seen that we have evolved and we have came long way, right from 50 Ah of the cell, today 314 Ah of the cell. Next year, most of the containers, they are being manufactured on 528, 548, and you can say 587. So till now, the industry was well matured. All of them are having a common platform of 314. But I believe in this competitive environment, different manufacturers are trying to put, you can say, go ahead in the race and then putting some of the cell capacities which are not on a common platform, which is pretty useful in the renewable industry, especially which you can say there are few manufacturing hubs, and then the deployment of these goods are in more than, let me say, in case not 100 countries, at least 50 countries in the next, you can say, few times, and especially the large utility grids like India need some of the stability. So at the moment, I believe this year is still a 5015. That's the container size what we have this year for most of our, you can say, shipment. But the next year is 625, because the cell size what we have next year is 528 and 548. And in fact, the lithium they have launched 1175. So that's another cell what they have been offering. But they are offering that cell for some of the very specific project. But what I see that we also need to have some of the associated thermal management from cell to pack lines. You can say you need to have a right pack. You can say configuration. You also need to have a lot of safety which is required to be evolved there. It is not that you just keep on increasing the cell size. You need to have a lot of insulation, fire suppression, cooling, which is all needed not only on the, you can say, pack, it need to be on rack, it need to be on container. So as soon as you keep on increasing some of the basic cell capacity, you also, your thermal management of the container also becomes a more tedious job. So I believe that's where the industry is evolving at this point of time. So that is one aspect of it. The second aspect of it, that what is the PCS what you need to put in. At this point of time, the mainstream PCS which is being used is 2.4 megawatt. So 2.5 or 2.4 or 2.5 megawatt along with 5 megawatt of the, you can say, battery container, which gives like 2 hours of the, you can say, standard, you can say, leverage. But once you have a different, once you are expanding this to 6.257 you can say megawatt and 9 megawatt hour of the battery container, then your PCS configuration also need to have a matching thing, or then you are using it for 4 hours, 6 hours, or you can say longer duration. So I believe these are some of the critical pieces which are required to be co-developed and synchronized, not only for a one equipment, I believe for a different generation of the containers which are being developed of the cell guys who are, you can say, trying to push in the, you can say, cell rating. I believe that's where industry is evolving at this point of time. And at the same time, the manufacturer like us and few of the other who offers the comprehensive solution along with the PCS and battery need to be mindful that how do we have the right combination of PCS and battery containers so that it has a longevity, because all these equipment are for 25, 30 year of the uses. These are not short-term uses. Maybe what we have seen that our utilities are saying that we need to have 12-year PPA. But this 12-year PPA is only the utility requirement. But the design life of equipment is like 30 years or 25 years at least. So that's where I believe we are today, and that's where industry is evolving at this point of time.
Thank you. Thank you, Yogesh. Ankush, we heard a lot about containers, and there is a misnomer, okay, in the industry that these containers are the same shipping containers that we used to ship. Can you break this myth and tell us what goes into making a container?
So these containers are not the same containers, right? So there is a lot of engineering that goes behind developing a single container. Be it starts from like say 10 feet container to 20 feet container and so on, right? So each and every aspect that you see today in Indian market, right? So a lot of people are struggling or like trying to make or replicate these containers which are coming from China, but it's not the same engineering, right? So there is a lot of raw material that we see today, which is specifically designed, developed in China, and then people trying to spend a lot of time on doing the reverse engineering in India, but it doesn't work similar ways, right? So here in JM and JWL, that what we had cracked so far is we have already developed a lot of containers, right? Where we are developing these systems for companies like GE, Schneider. We have our own integrations also going on 10 feet containers, 20 feet containers. So if you'll see the tests that are included for a container for BESS application, the sort of infrastructure which is required for BESS containers are specifically different. So here we have a facility of deflagration test that we do as per NFPA 68 standards, which ensures like just like we have in our battery pack, we have PRV valves, right? So that ensures if there is a high pressure or anything such condition, drastic condition when the battery pack goes into, the PRV valve will open up. So that is one of the safety considerations that we take in. Similarly, in this case, we have this deflagration test facility in-house developed, where we had put a lot of efforts to understand what's the right value to achieve for a specific container of a 10 feet or 20 feet, right? So these tests have to be done, these infrastructure has to be developed. Then talking about in terms of coatings that we do today on the sheet metal parts, those are specifically not as per the standards which are being utilized in shipping containers. These are much more than that, because you see a lot of different conditions where your containers have to survive, right? So the coatings that we do are specifically different. The paint that we do are specifically different, right? Apart from that, there are few accessories also which go into building a container for BESS application today. These are also probably taken right now from China. I think Rudra will also agree with me. Like there are a few accessories like corner castings that we today take it from China, because there are like no standards specifically designed as per IS standards in India, and the sheet metal part that comes specifically for accessories has been taken up right now from China, and China has done it in such a great way that in India people are not taking up those standards as such. So Indian standards are different and Chinese standards are different. What they have done is like they have read through what India has to use, but they are still connected to their roots, and they have been utilizing those particular standards now, which we are right now utilizing in India. So right now the whole objective is to work collectively, get these things developed in India from scratch, understanding the new generations which are coming up, right? Just like we discussed about cell evaluation, right? So the cell form factors are evolving so fast. That is how I think we should also have to do to understand each and every factor that we can incorporate in-house, and then develop these systems as per international standards, right? So that is the sort of journey that has been going on so far.
Thank you. Thank you, Ankush. Abhishek, coming to
Yeah,
you, I
yeah,
would
Dev.
like to understand from you a part of our chat that is PCS, right? What is PCS and how different is this PCS from the ones which we have used in wind and solar?
So, see, mostly like where we are utilizing these pieces, first of all, like is a power conversion system. So there, like we are using for charging and discharging of the batteries, and parallelly we are integrating with the grids with the different application types. So, like what we were using, like for initially for wind and solar, that like central or string type, different type of inverters we are using. So those are normally from the one side power flow or energy flow, you can see. But right now, where we are moving in terms of PCS, I think Shreyas can put more value in that being from the PCS side. So right now, we have a lot of multiple configuration from a normally PCS are coming from like 125 kilowatt hour till megawatt hour scale. So those we are connecting with the battery systems. So since there are two type of evolutions, one from the PCS side, which we are using like to charge the batteries, and same wise like on an intermittent basis, these pieces will require to discharge from the batteries as per the application, whether we are going for FR applications, we are going for a backup power applications like grid forming base, like we can decide how we want to utilize those batteries. But to coming like I heard a lot of things from Yogesh ji, Ankush also. So we also are like being a battery company. So a lot of focus we are putting towards PCS side right now in India. Many players we are integrating right now with our batteries, since we have developed our own battery system from low voltage till 1500 volt DC, using our own indigenous battery management system, which is a most critical part. So everybody is today is talking about the PCS, the BMS, but nobody is talking about the high voltage box, which is the intermittent part between the battery system and the PCS. So if like even if we are going for like 100 and like 1025 ampere hour cells, so we need to be ready with the balance of system like high voltage box,
Mm,
which includes like DC contactors. Today, if you go in the market, the DC contactors are available up to like 400, 500 amperes. But if you go for a 0.25 C rate, so you need at least 400 or even more. So that is another critical resource to be available. And
mm,
there are very few companies who are making high voltage box across the globe. So most of the Chinese companies, even they are not making, they are buying from the different resources. So there, like we see, once we are ready with the PCS, once we are ready with the high voltage box, so we are going to collaborate together,
yeah.
and should not be a challenge. Okay, from Indian point of view. So coming to the PCS, like Dev, to answer your question specifically, so this is the main device, which is going to create a balance between the battery, between the grid, and between the loads. So that is all connecting through the energy management system. So which is the most important part. I think somebody will take, I think maybe Ankit will take on that side. So they are like, I will keep a pause from that side. And PCS is going to be like the future in the India, and not only in India, across the globe. And parallelly, I think Shreyas will put more effort in that part. PCS, more PCS companies to be aligned, or maybe start not assembly, but I would say manufacturing in India.
Yeah. Thank you. And just on a personal note, I have seen Abhishek and Ankit rise. So from the initial days of Ankit pitching it at the startups competition of my previous company to today where he is, and Abhishek also from moving to a new venture and then picking it up from there. So yeah, I get motivated by these things.
Yeah.
Ankit, a question to you is on the warranties.
Yeah.
Okay. Today we have PPAs of around 12 to 15 years, and if it is with solar and FDRE, it is 25 years.
Yeah.
So people often talk about battery warranty, okay, but we do not talk about the warranty on PCS and others. what is the concern today?
See, I think when it comes to electronic systems and especially high voltage systems, it is very difficult to, first of all, for anyone to commit those long warranty cycles. So generally, it is something that is always a part of the extended warranty, and it is always that extended warranty is sort of also assessment based. So whoever is supplying will also do assessment on the completion of the previous warranty tenure, and based on the data of the system integrity, they'll say, okay, this system will last probably 1 year more or 2 year more, and according to that, they will underwrite and a certain extension of the warranty given certain conditions. So I think that's where the baseline is. However, when the financial, when we think about a project, when we think about a 12-year project or a 15-year project, of course, the financing, everything has to be done from a long-term perspective. It has to be done for the 25-year thinking, 15-year thinking, 12-year thinking. That entire thinking has to be there. But at this stage, unfortunately, only budgeting can be done when it comes to extension of warranties, unless, of course, somebody wants to take that risk of investing into warranty upfront, which I believe, given the competitive environment, nobody is interested in. And I think right now the most important discussion in that regard, so that at least 5 years later or 6 years later, that extension becomes possible, is around data itself. I think the fact that immutability of data, the fact that the data that is coming out of a DEPA compliant control system, these things will bring in bankability. And I think that bankability fundamentally will allow project beneficiaries to get that extension eventually. But that's my thought process in this.
Yeah. Thank you. Thank you. Rudra, I will come back to you and talk a bit about, dig a bit more into this topic. So today we have an announcement made by the ministry that EMS software has to be domesticated. Today or tomorrow or day after, this thing will also come in for containers as well as for PCS and other things. How much of container is today being built in India and how much of it is being imported as of today?
So, I think in terms of, I mean, how much, I don't think there's a real number to this, but I think most major players who are developing BESS in India, the complete solution, are sourcing containers within India. As Ankush was mentioning, these are not just standard containers which you can just, a little bit of welding here and there, and you can just, pass it off as a ESS container. They're built from scratch. In many cases towards a particular mindset or a framework of that particular IPI or IPP or the battery manufacturer who's integrating them. Because everyone has a different train of thought. You have the vanadium redox batteries, you have people who are doing straight up racks. There are some people who are doing detachable racks, liquid cooling. Everyone has a different mindset, a different approach, and that's what makes us a fairly diverse solution-based industry. So I don't think not many of these containers are coming from China. They actually have to be built in India because the integration of the batteries, as per many of the tender clauses, has to be done in India to take care of. So more and more as we're seeing almost we've worked with over 12 different ESS companies in India and developed containers and are continuously supplying to them from our plant over here. Because what we have to keep in mind, and I'll play off that point that Ankush mentioned, that people are just getting a container from China and trying to reverse engineer it. It's not possible because our standards of steel and their standards of steel are different. Our sections and their sections are different. So there is a little bit of a journey over there that's required to fulfill that. If you want to make it in India, I mean, people can, if there's enough money with the battery guys, I'd love for them just to get the components from China and we can make them the exact same containers here as well. But that's not practically possible. And that's not pushing our, case forward in terms of Atmanirbharta. So more and more, I feel that, I mean, again, I don't have a metric for you here because we don't supply to every ESS company in India. But from our experience over the last couple of years that we've been making these ESS containers, going back to about 2022 is when we made the first one. Actually, no, a couple of years before that. But going back that far, almost every ESS player who's getting into it at a decent scale is developing the containers in India, because the way that they also get to touch and feel the product, apart from taking a full team over to China to just go and see how a container functions, it's opportunity cost and it's actual revenue. You guys are talking about loading insurances on. You got to load these costs on as well. Those flight tickets are not cheap. There are no direct flights over there either. So, put in your hotels, put in your TADAs, put all of that towards your fixed costs. So, you've got guys like us and, Jupiter and a couple of more who are trying. You guys just got to come work with us. We give the solutions here as well. And while, there is a market leader, right, understanding, and there were a couple of messages on the group about BYD doing these, massive, but those are also not in containers, many of them. Those are those are just warehouses full of batteries that are being lined up. So very different solutions across the board. So these containers when we manufacture these containers, we have to keep in mind the ISO standard, which is ISO 1496, which is for freight containers. But basically, we keep in mind the dimensions and the structural integrity. For example, when I'm developing a container for let's say a company that wants to put about 5.5 megawatts of battery into a container, my container is weighing up to 40, 45 tons. So as per the testing standards, I have to test at twice that rated load. So I have to load that container with 90 tons of material before I can test it in the jig, which gives it its ISO certification. You can't do that to a standard container. It'll snap like a Perk XL. So there's just no ways you can just thoda sa welding karke usko aage badhao. So these containers more and more will have to be developed in the country where they're being used. We're seeing that happening in the US as well with whatever else is going on, and there are people who are making ESS containers in the US as well now, starting from scratch, because it becomes very area and industry specific. Our demands over here, as Ankush was mentioning, the demands of our weather, these containers are completely exposed. The beauty of putting a ESS into a container is that you can store it anywhere and forget about it for 10 years, apart from general O&M and a little bit of touch up here and there. So when they get slammed with the weather gods that we have in India, the coating systems are obviously different. So when you again try and get a standard ISO container, try and modify it, a standard ISO container has about 120 microns of paint on it at an average, give or take 100 to 120, right? They're made in, 400 containers a day, 450 containers a day. They're made in a box factory. BSS containers go up to C5 and CX standard of paint, which is got a coating of almost 3 times that. So it can, weather the storm for much longer. We're talking about tenders that are out for, 25 years, 25 years of life cycle. So you require coating systems that can take that on. So that's why, while again, I don't have a metric, and maybe you have a metric about how many containers are, that'll be really interesting to know how many of the ESS containers more and more are, from China. But I think that number is on a decreasing path, because your tender requirements of indigenous content gets easily taken care of if you have an Indian container.
Got it.
Plus, people talk about getting containers from China. That's not cheap. If you're getting that container into India, you're firstly paying a 30% domestication fee, which takes away your duties, a GST on that, a couple of more line items. So you take whatever price you're buying it for. Secondly, if you're buying one prototype, good luck. Very tough to just get one container. Very tough. It's very tough. It's open knowledge. And then if that prototype has something a little bit off, you can't send it back for repairs. Like it's really not that easy.
Yeah.
And once that container, firstly, the container has to come empty. It can't come loaded with goods because you guys have your own configurations inside. You have your racking system inside, whatever you have inside. So it's coming empty. That means you're paying full freight on it. Then you're loading it up with about 28 to 30% of domestication fee. It's a layman term. That's a breakup which someone can provide, and that's okay. So it's really not that practical to actually bring them in from anywhere else in the world, bar China, anywhere else.
Interesting.
Yeah.
Thank you. Yogesh, I want to come to you now and ask you a very interesting question that has been the talk of the town. One is the GST. The second is what is the customs duty? Okay, people have been taking all numbers of customs duty, but the exact number. So, so just to clear this mess, I want to ask you, what is the BCD that is on containers and what is the tax on it?
Yeah, see, our understanding is that for the energy storage system, basically, which is a container, the basic custom duty is 10%. So that's what is the basic custom duty. And then the GST remains 18%. So there is no reduction of the GST in the present scheme of things. The GST has been reduced on my understanding is inverter and module from 12 to 5, but on the battery it remains 18. So once you are getting in, you can say the container from, you can say, energy storage system as per the, you can say, norms, at that point of time you need to pay the 10% basic custom duty and the 18% of the GST. On top of that, this also gets loaded with the freight, because all these are dangerous goods. So these comes in the DG category. The freight is not, you can say, same or the normal freight, with which you get a 20-feet container or 40-feet container. Your 20-feet container can come in, let me say, $1,000 on a good month. But these containers, the freights are very, very different because they need to come in the DG, you can say, category. There is a special clearance which is required to be done at the port of origin. There is a special clearance which is required on the port of discharge. So this comes with its own complication. And then on top of this, I believe we also need to be mindful that weight of these containers, in case we take a standard 5 megawatt, which is basically 5015, you can say kilowatt hour of the battery, the weight is not less than 37 ton. And it varies from 37 ton to, you can say, close to 40 ton. So these are, again, very, very sensitive to manage. And as Rudra was mentioning, and then I spoke, you can say, earlier, now the cell ratings are going on. So as soon as your cell ratings are going on, your weight is going to increase. So in the future, and then shipping has also some of the limitation in terms of loading these containers. So probably I don't think you can do a container shipment which is more than 42 ton. I mean, that's these are some of the other limitations. And maybe on some of the major ports, you will have all this infrastructure available. In case the ports are, you can say, smaller ports, then some of the infrastructure may not be available on some of these smaller ports. So logistic is one of the most critical issue in once you can say get these transported either out of, you can say, foreign country, or you can say you are getting imported or you are getting it shipped domestically, because some of the safety which are needed for loading, some of the transportation as well as unloading is very, very, you can say, sensitive topic. And these are some of the very high sensitive area in which one need to be very, very cautious in terms of EHS and safety norms. So I believe these are pretty sensitive things once we do any of the project execution, EPC, as well as project development. So all of the, you can say, the stakeholders in the whole project, right from lender, right from, you can say, developer, EPC, as well as off-taker, they're all very sensitive that how the safety is being managed. So this is where, you can say, the logistic and some of these border sensitivities are, and one need to be very mindful that what is required to be taken and how the whole value chain, or you can say logistics supply chain, is being maintained.
Thank you. Ankush, I want to come to you. I know that Jupiter does much more than containers. And so one thing you explain about that, but before that, just a simple question. Are our ports ready to carry these containers? So when they come, when the shipments come, 40 or 60 tons per container, right? So are our ports ready to carry these containers? Is one
Yeah.
question. And second, of course, is what apart from containers are you doing?
Yeah. So definitely these ports are well equipped with such infrastructure where you can import all these containers, right? So when I say like people or like companies are importing these containers, that's majorly when people want to do liquid cooling systems right now in India, right? So there are like two types of cooling systems. One is like HVAC systems, and then another one is a liquid cooling system. So that's where the major game comes in right now. What even companies like us are developing these liquid cooling systems in house, right? Getting the infrastructure ready done, designing the complete ecosystem in house to have this competency, right? That we can grow. So liquid cooling system, whenever somebody as a complete pack sells in China, they will sell it in such a way that you have to import it through and through from them, right? So they won't give it in parts, right? HVAC system definitely, as Rudra mentioned, like people are doing it in India, which makes sense as well. But liquid cooling system, there are n number of auxiliary components where you have to take care of each and every pipeline, the ports and everything, right? Even if something is here and there, you just lose the complete game. And that is where the warranties kick in when you have a cooling system, liquid cooled, where you are more giving a guarantee of higher life cycle as well. But unfortunately, I don't see major players right now in India developing those systems or even trying to invest with any company so far to develop those in India, right? So even if you'll see for cooling plates for mobility application, right? So the cost of development is so damn high. Like even companies who have not much
Research actually.
invest, right? They can't even invest on the cooling plates. They can't invest on the cooling pipes as well. So people will charge enormous amount of money where you put your hands down and you will say like, okay, I will just import it from somewhere else, right? That is the situation. That's the right situation. So here in Jupiter Wagon, right, as I earlier told, we have almost supplied around 2,500 containers this year. It would be going almost 3,000 containers so far, right? So we have developed that competency. We are doing HVAC systems. We are doing air-cooled systems. Liquid cooled is something that still we are figuring out probably in next 8 to 12 months. We will be ready with our own system as well, right? So we have invested a lot developing these competencies in house, starting from testing, paint shops, developing products for Fortune companies, 500 Fortune companies in India, right? Even we are exporting a lot of containers outside India as well, right? So container part, we are well equipped, well versed with all the technologies framework that is required. And as Abhishek mentioned in between the call, right? So PCS definitely is important part, but EMS is also something which is very much critical. So the brain of the complete
Yes.
PCS is the EMS. So
Yeah.
definitely a lot of regulations have come in, which is in favor. I think which is favorable to all of us who have been putting up a lot of efforts from past 1 year, 2 years down the line, developing these BMSs and EMSs. Because getting an EMS from China, they have already developed it, right? So they are selling it as it's just a product for them, which they have already supplied a lot. They have already basically they have already got the revenue that they have invested for so far, right? But in India, when we are investing a lot of money right now to make EMS systems, EMS systems in house. Definitely, these policies which have come recently from Ministry of Power, right, where to get the VGF scheme, you have to have an indigenous BMS. And that's not just the one thing which has helped us, but again, getting these AMS, BMSs developed in-house or in India will definitely help us to secure all the data. Here in India, our infrastructure, our grid are completely different from how China works today. Our frequency fluctuations, our voltage instabilities are different. Our in our country, this is very regional right now. So I come from northern part of India. I see. I remember still we face a lot of challenges in rural part, tier 2 cities in North India where there is a single phase, right? So all these things can be managed well when you have a base with a smart EMS system, right? Which will basically manage all these fluctuations, all the frequency fluctuations, voltage fluctuations. So that is where we have been working so far to get these systems developed in-house, have the complete ecosystem so that it can be at par with external market outside India as well.
Sure. Thank you. Shreyas, coming to you, I want to understand, to everyone's understanding, just explain what goes into making a PCS. What goes into making a PCS? Yeah.
So, I'll introduce myself Shreyas. So, I'm representing FIMER. So, when you ask about PCS, it's more like how the solar inverters were used for solar plants. PCS is used for BESS plants. So, in our R&D unit, we didn't have to do much of a R&D to change the solar inverters to PCS, because our firmware was very flexible. So we did minor changes and a few components, like for protections, you would have your DC contactors, your fuses, and you would have your power modules. So basically semiconductor power modules. And for all your grid connections, you need to have an ACB. So in the bigger context, I would say like a PCS is something, like a muscle for a human body. And an EMS will become the brain for this PCS. So if you want to command our PCS to perform any actions, let's say regarding discharging battery, or even the basic such as turning on and turning off the PCS, everything is always controlled by the EMS. And when you talk about advanced features, let's say grid support features, which include ancillary services or voltage regulation, frequency regulation, these are all special applications. And from our PCS end, what we do is we just supply power to the grid, and we convert the power from battery, we transform it to AC, and then we power and we supply it to the grid. All the application part is always taken by the EMS. So that is how our PCS is designed, and which is very similar to what our solar inverters used to do. And in terms of protection, yes, because when you talk about batteries, they are all 1500 volts system. So the short circuit current, in case of any damage from the cells, they are very high. It not only impacts the battery, it impacts all the further systems. Our PCS can be impacted, even the up to transformer can be damaged. So in case of that, we had to design a very specific fuse for all the for different battery container sizes. And yes, coming to battery container sizes, like you said, the market is running on 5 megawatt hour battery containers, and our PCS, yes, it is capable of 2.5 megawatt. And in the future, even if let's say the market jumps to 6 megawatt hour or 7 or 9 megawatt hour, we have our PCS, which is let's say future proofed, so we can go up to 4 megawatt, so no problem. Yeah, so that is like one of the features that we have, because we have worked, before moving into the Indian market, most of our PCS was for all export jobs. We have tried and tested many of our products for many projects in Europe and other countries, Middle East and all. So we've been supplying it from 2019 and 2020. So we have a clear idea about how the PCS is capable of operation for all different scenarios and all different conditions. So yeah, that's what I had to say.
Thank you. Thank you. Abhishek, this two cycle thing, we have been seeing the 2 hour 2 cycle thing, right? In our present tenders, we have been seeing just in India. We haven't seen 2 cycles across the world in majority of the places. Now I want to understand. So apart from degradation of batteries, okay, how is PCS or EMS of a battery taking care of this? Just a pointer to my audience. Please put in your questions in the Q&A box. I will pick up the questions from there. Yeah, Abhishek, over to you.
Okay. So see, in most of the utility scales or FDRA tenders, wherever we are seeing, so mostly like earlier we were making a tariff structure for a 25-year life cycle. Now most of the things are converted to 12 years, like 2 cycles per day. So ultimately it is covering that again 25 years. But like from a design point of view, it is little tough. So what people are thinking, 2 cycles per day, like Shreyas told, so you should have a charging capability of the battery system, which you are going to configure. Somebody is taking care for like 0.5C or 0.25C rates of charging of the batteries. Definitely it is possible. Then you have to do the oversizing of the PCS so that you can get additional power to charge those batteries for a 2 cycles utilization of 2 cycles per day. Second is like most importantly, like that depends upon the application as well. Like if you have not much sun radiations available those days, so you will not be capable if you're going for a 0.25 or 0.5C selection of the PCS, so that it can charge your batteries in 4-5 hours. Like in some rainy days, you will not get sufficient time to charge your batteries. So ultimately, like that's why we are keeping a capping of round trip efficiency or CUF factor of 85 or even more than that, only to get like we can get an average of rather than putting my point of view, say like 2 cycles per day, they should come up with a combination of throughput of the energy, not with the cycles per day, because that all cycles we are calculating on the basis of cumulative numbers. And that can be add on. So rather than going with the cycles per day, which are most of the BMS companies are not able to design a cycles. Okay, maybe sometimes I will go with a discharge of, let's say, 70% SOC, 80% SOC. So that is giving you a cumulative number. But the day you will start working on a basis of throughput, like kilowatt hour, this much of kilowatt hour we charge from the batteries, and we can calculate like it like a cost of compute basically. What you are charging, what you are utilizing. So this is a very interesting factor that can be built in. So 2 cycles per day, definitely without PCS, it is not going to happen. You can more and more batteries, but if you don't have the power source to charge those batteries, it is not a viable option for any BESS companies.
Okay, cool. Ankit, we have been talking about the utility scale at large, okay? But what we forget is the BTM market, behind the meter market, and the CNI market. Of course, it has not opened up yet, but I would love to see that open up very soon. And the day it open up, it will just blast. So I think looking into the CNI market, how do you see this entire game playing out?
Very loaded question. Okay. So for example, first of all, I think it is extremely important to identify different opportunities in CNI market which can be scaled up. I'll take one example. We are doing a project where we are doing there's a concept we developed for the first time, and this will be happening for the first time in India itself. And we are basically using a BESS with a captive thermal plant. And we are basically going to do load balancing for the manufacturing facility over there. Now, in this case, the battery is going to cycle in a very different way. First of all, the operation of the plant itself, the BESS plant itself, cannot be deterministic. It will be probabilistic. It will not be deterministic. It will be completely probabilistic, right? So you do not have any. Let's say if I tell Abhishek tomorrow, okay, give me warranty on this, Abhishek will be like, "Bhai, mere ko nahi pata." Yeah, so that's I think CNI, first of all, when we It has to go through a lot of evolution. It has to go through a lot of evolution from all fronts. I think I'll just call back on Rudra's point also. If for CNI, you need very different kind of container design itself. It cannot be, you cannot just simply import the China container and make it work in CNI. And it's according to the, let's say if it's a data center, it's a different kind of application. If it's a steel manufacturing plant, it's a different application. If it's a hotel, so it's a different thing, and it's a hospital, it's a different thing, right? Your safety norms completely change. Your everything changes. But there needs to be a lot more scope to customize as per the facility for which that project is getting commissioned. Also, right now, most of the CNI applications, let's say if anyone, you will see majority of the CNI discussion in BESS context happening generally in the form factor where the BESS is getting co-located at the generation side itself. The discussion of locating the BESS in the customer complex itself behind the meter. That's still a far off discussion.
Yeah.
The project that I'm talking about, the captive thermal project, we are doing it behind the meter itself. It's behind the meter in the complex of the customer itself. And it will test out a lot of things. It will give us learnings about a lot of things, which we'll of course share with the ecosystem so that the suppliers for various components can bake it into their product PDLC, and accordingly we are also able to leverage these components locally itself. So CNI requires, first of all, complete top-down exercise. It requires complete top-down from application to exactly what will be the outcome, what kind of material will be required, how will we sustain that project in the long run. वो मतलब अगर उसको कंपोनेंट भी नहीं मिलने वाला है तो आप कैसे करोगे उसको? So CNI is it is the place where things need to be focused now, given the scenario. I think all of us understand what I'm talking about, but it requires a lot of focus. But वही उधर ही focus भी करना पड़ेगा, otherwise yeah.
Interesting. Thank you.
अंकित EV चार्जिंग इंफ्रा के लिए भी काफी कुछ बोल गए from a CNI point of view.
Thanks. Yeah.
No, I think Abhishek, just to EV charging wale point pe bhi, I think we can look at the best AP regulation.
Absolutely.
And I think he's referring to that itself. So V2G is something that I used to talk about it 2-3 years back. Now it is materializing, and it's heartening to see it. We did the first V2G pilot of the country.
Yes. Yes.
Yes. Later on, the norms from there were adopted in the battery swapping guidelines. Battery to grid wala jo pura concept tha. Now it is also coming. So ये होना है, मतलब this is good. It's necessary also. But yeah, I mean, we'll have to collaborate in a very big way. Yeah.
Ankit, I think अभी तो blockchain भी आ गया. So definitely V2G is going to be the buzzword in next 6 months. Not more than that.
Yeah.
Nothing will be possible.
So I just want to add on to that point that Ankit was talking about, and I'll just pick up that one keyword he used, which is collaboration. We need to do it. I've been now, this is my third industry that I've gotten into, which our group has not been in earlier, and including drones. And this is the era of collaboration, and I'm yelling this from every rooftop that I can find before I finally fall off one in this case now, because I'll just keep yelling it louder. The role of Ankush and my company in this case is a component supplier to the overall industry, right? But the way that, we have a tendency, and maybe it's us as Indians, unfortunately, that keep cutting each other in our tenders just to grab that business and make it at unscalable, unsustainable numbers. It's just not the way forward. I mean, this is an industry where you have an advantage of not having just an L1 position. Even if you see the large Chinese tenders, I was just reading just a couple of days back, they closed out a very large tender, and then even L4 was given a volume of that tender. And if we need to get and push, and we need to keep saying this as an industry that it is not the way forward, boss. I've seen in front of myself two industries really struggling with this issue. And this industry, I come back to my first point that Debu had mentioned about, where do you see yourself in 10 years? And why I was so hesitant is that if we go down the L1 route in this industry, there will be no industry. We will go straight to hydrogen. We will skip this journey of batteries. It will only be by the big boys, and you will never have startups succeeding apart from component manufacturing or, some sort of sub-assembly or sub-component level manufacturing. So, I keep, we're a part of the same alliance over here. And I urge everyone that keep pushing for collaboration, push down the, talk of L1 over here. It's just not the way forward for a startup and a nascent industry. It's just not the way forward. And again, I'm going to say what Ankit said, it's collaboration. It's the only way forward. This is the era of collaboration.
Correct. I would have loved to continue this, but just one point by which I want to say goodbye to you. A recent battery storage tender by one of the states saw 50 bidders submitting bids. I repeat myself, 50 bidders submitting bids. And here we were thinking that maybe now the price will rise. With all the story of global lithium prices rising, supply demand issues coming up. So I mean, it is great from one part of the story if you want to paint one part of the story, but it is equally not great when you see it from another part of the story. Your feedback, the final one. I will start with Yogesh.
Yeah, probably see, let me put it this way. See what is happening at this point of time. People have wrong perception that energy or battery storage is just a PCS container and a battery container. I believe that is a completely out of, you can say, market, out of design. This is not something people have, you can say, any understanding at all. So it is not only the PCS and battery container which are required as some of the major component, and especially once India is having two cycles, you can say two duty cycle, which is not there in anywhere else in the whole world. So people don't even understand what type of cables which are required to be put in. The cable ratings have to be very, very different, because then you are charging and discharging for the whole system for like 10 to 12 hours a day, and sometimes even 15 hours a day. So your all the, you can say, your accessories, your protection system, your switch gear, then the duty cycle is very different, which is for which some of these equipments are not even designed. So people have a wrong perception that now the battery you can say prices have came down, the PCS price is, you can say, very competitive. Let me put the bid, and then let me try to be L1. I have not seen that there is a detailed engineering which has gone into the complete life cycle, or you can say complete, you can say, design life of 25 years, which are required to be, you can say, considered once you design all the protection system, switch gear, DC, cooling system, as well as the cables. These are something which are required to be taken. I believe that's where we lack, you can say, some of these bidders lack, you can say, complete understanding. So they have absolutely no idea what is required to be done. They are just thinking, let me put one container, one, you can say, PCS, and then try to win the bid. I believe that's not something which is going to, and then we are a tropical country. Our temperature in some of the regions goes to 52 degrees. Your auxiliary power requirement for the cooling system itself will go, you can say, something which will, you can say, eat away your RTE. So people don't understand this, and I feel we need to have some of these healthy discussions, and we need to have some of the learning which are there from some of the market which have deployed some of this energy system, you can say, a few years back. And I believe there are many examples. So China has been doing it from last at least 7 years. They have, you can say, 20% mandate in the renewable form. Your Australia has more than 15 gigawatt of the operating capacity at this point of time. They are doing at least 10 gigawatt of the battery storage every year. And then the most, you can say, large part is energy arbitrage. So that's what they have been doing. So all this, I believe we need to have. And then at the end of the day, we also have a great talent here. There's absolutely no shortage of the talent in India. In fact, you can look at some of the global market. Most of the chief engineers, most of the design engineers are all our Indian friends, or our Indian brothers. So that's where we have been designing for the whole world. But I believe at home, we need to do a better job. So that's what my feedback would be.
Thank you. Ankush.
So, Dave, I think the way forward should be definitely, as every panelist said, like collaboration, right? So, whatever is available in India fulfills the need of these tenders, right? So, we should definitely adopt those products, right? And then at the same time, in-depth engineering is very much required, right? So, it's not like you get the cost of the lithium today, and then you don't know after like 12 months when you have delivered the product, you don't know the right cost, because there is nothing as such flowing up from past 10 years that lithium prices have been like increasing like 1%, 2% year on year, or like it will drastically either go up or drastically go down, right? So that is where the major bottleneck can come in, right? There is nothing as such data so far, right, where we can predict after 12 months what will be the exact cost of the cell, right? What is the exact cost of the complete system? So definitely, as new cell manufacturers are also coming in, right? So we should start collaborating with them. We should adopt their cells. We should do the pilots with them, understand how the pricing will go in the next 12 months or 24 months, or like at least have a span of around 6 to 7 years of visibility. So we definitely need all these collaborations, and indigenization of each and every component is very critical. In-depth engineering we have to do for sure as per the Indian conditions. It can't directly flow from China or Europe. Like whatever has worked over there will definitely work in India. It's not going in that direction, right? So I will just give an example which I heard from one of the OEMs, right? So they had an IP55 rated container, right, installed in Rajasthan. And then in the night time, there were like sand dunes and like winds coming in, and their HVAC system was getting blocked after every like 1 week, right? So those sort of challenges people won't face in China. They won't face in Europe, but definitely they will face in India, right? So having an indigenized solutions working collaboratively will definitely help us to become a better country, to fulfill the requirements and develop a good product. And that definitely we can, if anything works in India, will definitely work outside India as well, right? So that way the journey should be.
Thank you. Abhishek, last words.
So, see, Dev, I will just put a remark on your query. So, you remember like the first BES standard, 10.87, if I'm not wrong, was the tariff that time. It is not executed in 4 years. So, we need to first filter out the bidders. That where we need to put some owners engineers from whether it's from NHPC, SECI, or anybody else, to filter the appropriate bidders. This is most important part. I will tell you one story, small story. Like I heard somewhere, like in 2009 or 10, for telecom sector, there were 32 bidders for the rectifier manufacturing. And in 2025, there is only 3 players who are making manufacturing of the rectifiers. So you can imagine the shift from 32 to 3. The same way you can imagine like 50, how much it is going to be in the future.
Interesting.
Sorry, can you hear me?
Thoughts.
Yeah, so I believe I honestly see this as a good thing. So it may be contrarian, but just the thought process, it's just an alternate viewpoint. And the viewpoint is this, that right now, it's very clear that we haven't successfully indigenized cell manufacturing yet. So I think at this point of time, we are highly dependent on our global counterparts. And it is extremely important to signal a strong appetite as a country for this kind of a asset category. And I think this kind of competition in tenders is signaling that.
Yeah.
So in that context, I see this as a positive thing. Now, while implementing projects, of course, we need to be cognizant of all the risks.
Correct.
But that's the overarching thought. Yeah.
Shreyas?
Ankit, that's why I was asking for the filtration of the bidders.
Yes.
Yes, sir. So, like I said, the battery prices is what actually, compels everybody to jump into the tenders because, like from the, past 10 years, we've seen the battery prices drop. So people are getting more captivated into, BESS and stuff. Yeah, like I said, its implementation is much more complicated than what it is on the surface level. You have to do many grid studies and stuff. You have to plan your, I would say, your block sizes and everything and stuff. So yeah, if you can collaborate and even the DCR content, I mean the local indigenous manufacturers for cell containers, and we ourselves have a PCS that is DCR content compliant, and having more indigenous players would push all this tender in the future as well. So I would say it is a positive sign. But yeah, it will take a lot of time to come into surface how all this best systems work out, and that would probably push us into the top, I would say top 2, top 3 as one of the best battery, I mean the best operators in the world.
Great. Thank you. Rudra, finishing off with you. You're on mute.
Yeah. So,
Yeah.
So, I mean, I just come back to my point of collaboration. I think we need to stop worrying about component level sourcing at this point. I think, as Ankit and Abhishek ji have been saying, and Ankush has been saying, that it's all available here. The cells are a problem, and that will continue to be a problem for a bit. It's a nascent industry, and we can rely on it. And मैं योगेश जी की एक point उठाऊंगा कि आप लोग बस don't just look at the cost of the product, but look at the overall infrastructure required to implement these jobs, right? Why can't, one of us just start doing civil engineering? It's not your expertise. You're going to tie up with someone to do that. There's a level of civil engineering required. And this is not being considered when these quotes are coming out. And I just feel as an alliance, we need to push forward to the government and push back and say, as Ankit says, look at the positive synergy that there is a demand in the market, is being pushed up. We will keep fighting it amongst each other unless we, release that energy in the correct direction. And that comes in the form of VGF, that comes in the form of PLI. Not everyone can become a cell manufacturer. But can some people start? I mean, the government can become cell manufacturers. No one stopped that, right? If that is going to be a key raw material, then it can be taken up under a single central onus, which can be utilized by various companies as long as there's scale. But I just come back to, the same thing in container manufacturing. We talk about we want to fly before we can walk and run. So let's start walking from crawling, and then we take this up, take it up a notch.
Brilliant. I couldn't have asked for a better panel. Thank you, everyone, for joining in and such sporting spirit. So, yeah, thank you. I would like to take a picture. Everyone smile. Thank you.
Thank you, Dev.
Thank you, sir.
Thanks,
Thank
everyone.
you. Thank you.
Thank you.
Take care.
Bye-bye.
Rudra. Bye.